Welcome back to Educator.com. We're going to look at a few more examples on trying to find hypothesis tests for the difference of two proportions. So in our first example here, what we're looking at is in a study of 22,000 male physicians, half were given regular doses of aspirin and the other half were given placebos. Among those who took aspirin, 104 suffered heart attacks. Among those who took placebos, 189 suffered heart attacks. Test the claim that the aspirin group has a significantly lower heart attack rate. Use the significance level 0.01. Let's make P1 be the proportion of people experiencing heart attacks using aspirin. And let's define that second proportion as the proportion of people who take the placebo, who actually have a heart attack. So as always, we're going to see, well, let's assume there's no difference between the two. So P1 minus P2 is equal to 0. If I am assuming that the aspirin group has a significantly lower heart attack rate, then P1 minus P2 should be less than 0. Right? That proportion P1 should be a lot smaller than P2. Looking at this, my entire amount of significance is all in that lower tail, 0.01. Okay, so I need to find P1 hat. So there were 104 people divided by 11,000 who experienced heart attacks. So this should give me approximately 0.009. P2 hat. Well, there were 189 patients, well, physicians, who suffered heart attacks out of the 11,000 who were taking the placebo. And that equals 0.017. I also need to calculate P bar. P bar is going to be 104 plus 189 divided by 11,000 plus 11,000. When I calculate that, I get 0.013. So now I'm ready to construct my test statistic. I'm taking P hat 1, which is 0.009. I'm subtracting out P hat 2, which is 0.017. And I'm dividing by 0.013 times 0.987 times 1 over 11,000 plus 1 over 11,000. When you calculate that, you should get -5. So when we calculate our p-value, assuming the null hypothesis is true, it's the probability that we get what we observed or something more extreme in the direction of the alternative. So I'm taking z less than or equal to, why? Because my alternative is less than -5. Well, this is off the chart, so the p-value is approximately 0. So we're trying to see, is the p-value less than or equal to alpha? Well, my answer for that is yes. So what am I going to conclude? I'm going to reject the null hypothesis. So we would conclude that taking the aspirin has significantly lowered the heart attack rate when compared to a placebo.